Now let's look into the next principle. Now that we saw off bar tells me in what order I have to arrange the electrons. Okay. So in the orbital, in the veetla pona modalla first wind, second wind, third wind, we saw that. Now second thing that you are going to see is Pauli's exclusion principle. What Pauli's exclusion principle says is, the actual statement would be no two electrons can have the same set of 4 quantum numbers, meaning nobody in your city, okay, can have the exact same set of unique ID. Aadhar number one da irukum oralukku. Similarly, electron will not have the exact same quantum number, 4 quantum number compared to the other one. Let's say for example, this is your room. So there is 2 of you. Okay. You guys will have the same street, same house, same room, but your magnetic quantum number is different. Okay. Similarly, for example, there is an adjacent room. Okay, pakkathile or room irukku. This person and this person may have the same house, same street, but they have different rooms, and inside the room they are different. So you cannot really have exact same set of 4 quantum numbers. They can have 3 quantum numbers same, 2 quantum numbers same, 1 quantum number same. For example, let's say for example 2 electrons. Let's say we take oxygen. So oxygen has 1s2, 2s2, 2p4. So I have this. Three, 4. Okay. So now let's look into this electron and this electron. They have the same n value, same L value, same ml value, but different spin value. Let's say for example, I'm going to take this electron and this electron. What do they have same? They have the same L value. Rendume s orbital, L equals 0. They have the same ml value. ml values are assigned as 0, 0, minus 1, 0, plus 1. Similarly, d orbital 5 box போட்டிங்கன்னா minus 2 லேருந்து ஆரம்பிச்சு plus 2 போகிறோம். ரெண்டுமே ml value 0. So they have the same ml value. Do they have the same spin? Yes. So they have the same ms. But what they don't have the same, n value is different, 1s, 2s. Similarly, when I take any of them here, இதுவும் இது எடுத்தீங்கன்னா என்ன சேமாக இருக்கும்? These two, n value same. Okay, ஏன்னா ஒரே தெருவில் தான் இருக்காங்க. L value same because L equals 1. Now ml value, ml is 0, ml is plus 1. So they are not the same. ms value, they are both plus half. So same. So they have the 3 of them same, but you cannot have 4 same. That is your Pauli's exclusion principle. Now the last one that you need to know is pretty straightforward. Hund's rule of maximum multiplicity. Now what Hund's rule says is, basically you have to fill all equal energy orbital with 1 electron before pairing. Okay, the analogy would be is, for example, let's say in your house you have 4 pets, cats or dogs depending on your cat person or dog person. வீட்டில் 4 நாய் இருக்குன்னு வச்சுக்கலாம். Now if you have food, obviously you will put equal amount to all of them first and then you go to feed the other person, right? அதே மாதிரி தான் equal amount போட்டாகணும். That's what we do here. So let's look into oxygen itself. So I put my first electron here. Second electron எங்க போடுவீங்க? You have to put it here. You don't put it here. இங்கே போட்டால் என்ன violate பண்ணுறீங்க நீங்கள்? Off-bar principle. So I cannot put it here because lower energy is unfilled completely. So I put it here. Then I put the other electron here. I won't put it here. Okay. So I don't violate off-bar principle. Now the next electron, do you do this way? No. What do you violate now? You violate Pauli's exclusion principle. இந்த மாதிரி போட்டால் ரெண்டுத்துக்கும் 4 quantum number உண்டு. So I cannot do this. Hund's rule takes part only from p orbital. ஏன்னா அங்கே தான் வந்து multiple rooms இருக்குது. இதில் ஒரே ஒரு room தான் இருக்குது. So I have 4 electrons. If I do this, okay, I am violating Hund's rule because I have not given 1 electron each for all of them. So you have to give 1 electron each. Alright, let's look at an example. let's say for example we have this is what is given. Now what all is obeyed, what all is not obeyed. Now have you obeyed Aufbau principle? No. Aufbau inge violate irukku. How can I not fill this completely but go here? So Aufbau is violated. So Aufbau is violated. Now let's go to Pauli's exclusion principle. Is it violated? Not here. ரெண்டுத்துக்கும் வேறு வேறு 4 குவாண்டம் நம்பருமே இதுக்கும் வேறு. பட் ஹியர் ஐ disobey Pauli's exclusion principle. ஏன்னா ரெண்டுமே ஸ்பின் அப்பாக இருக்குது. ஸோ I have violated Pauli's exclusion principle. Now last is Hund's rule. Have I violated Hund's rule? Yes. There is an empty orbital here. I am pairing here. Pairing cannot happen until all available orbital of equal energy. ஹையர் எனர்ஜி வேணாம், இது மூணுமே ஈக்குவல் எனர்ஜின்னும் போது நீங்கள் வந்து எல்லாம் ஒரு எலக்ட்ரான் போடணும். ஈக்குவல் எனர்ஜி ஆர்பிட்டலுக்கு ஒரு நேம், பர்டிகுலர்லி இன் கோஆர்டினேஷன் கெமிஸ்ட்ரி இட் வில் கம், இட்ஸ் கால்ட் ஈக்குவல் எனர்ஜி ஆர்பிட்டல்ஸ் ஆர் கால்ட் degenerate orbitals, meaning same in energy. Degenerate in English normally referring to a person is actually a derogatory term, bad term, but in terms of this you want to put one electron in all degenerate orbitals. So Hund's rule is also violated because this is there. Alright, now why should I put one electron each? Maximum multiplicity you are going to see based on stability pretty soon. Okay, so make sure that you understand each of them very clearly so that you can answer questions based on this. Okay, based on what we seen before, we are going to explain why fully filled and half filled are extremely stable. The stability order follows this criteria. Fully filled is more stable than half filled, more stable than the rest. Why is it so? It's two reasons. First is symmetry. The second is exchange energy. We'll look at the exchange energy first and go back to symmetry. For example, if you take your p orbital, I have 3 electrons. Now what can happen is they are degenerate. எல்லாமே ஒண்ணுதான். So it's just like for example there are 3 kids in your house. Okay, உங்களுக்கு ரெண்டு அண்ணனோ தம்பியோ இருக்காங்க. There are 3 rooms, so you can interchange the room. So does it make you happy changing the rooms? Obviously yes. Personal problems aside, obviously yes, this is good. So now how many interchanges can I make? You, this is you can go to your first sibling room, or they can interchange with you, or they may not like you, they can interchange among themselves. So there is total 3 exchanges. So every time you exchange, energy is released. Chemistry energy released is very good, exothermic. வெளியில energy போக போக நீங்க ஸ்டேபிளா இருப்பீங்க. So 3 exchanges are there. Hence half filled is stable. Now when you look at this, how about fully filled? How many exchanges are possible? This is really interesting. So only spin up can exchange with spin up, spin down with spin down. So the spin up can exchange here, and this spin up can exchange here. Similarly, spin down can exchange here, and then these two can exchange here. So there is 3 spin up, 3 spin down transitions. Okay. Also, as a pair, you can do this. So as a pair you guys can do this. So total 9. Okay, so hence you have a lot of exchanges. So fully filled is more stable than half filled. Half filled is more stable than the other ones. Now if exchange energy is so much, let's say for example I have the 4th electron. What is the number of exchanges possible? Still 3, right? Still exactly 3. அப்போ எதுக்கு வந்து இது less stable compared to this one? This is where symmetry comes in. Symmetry means equal இருக்கிறது, எல்லாமே ஒரே மாதிரி இருக்குல்ல. So symmetry plays a role. Symmetry is extremely good in nature. Human body is symmetrical. So this is more symmetrical than this. Hence half filled is more stable than the rest. Okay, so this is how you want to remember. Now How about d orbital? How many transitions are there? Try it yourself. Now if you see there, the total number of transitions for a half filled d orbital is shown here. If it is fully filled, try to calculate the total number of transitions. Extremely simple. Usually அந்த pattern வரும். Orbitals வந்து 3 orbital இருக்கு. So how many transitions are possible? 1 2 3. 3 orbital இருக்குன்னா 3 transition spin up க்கு, spin down க்கு 3, and then total 3. Now let's say for example you have d orbital 1 2 3 4 5. How many are possible? 1 2 3 4, and then this can go here 5 6 7. Now I can look into this one 8 9, and this can go between themselves 10. So spin up is 10, spin down is 10, spin up and down is 10. So sorry, this is 10. So how about d10? This is d5. d10 க்கு வரைஞ்சி பார்த்தீங்கன்னா you will get this. Spin down போட்டிங்கன்னா spin up க்கு 10 வந்தது, spin down க்கு 10 வரும் இதே மாதிரி spin down க்கு, and then totally வந்து பேரா மாற்று 30. Hence half filled and fully filled are much more stable. Now nobody is asking you to draw all this. If a question comes, they might ask you which one has the higher or lower exchange energy, or how many exchanges are possible, or a statement question like theory question, symmetry and exchange energy. Alright. Let's look into shape of orbitals. You might have already seen in school, but regardless, please do listen. Shape by itself is very simple, உங்களுக்கு ஞாபகம் இருக்கும். But there is a next aspect of shape that you want to know for NEET, but we will cover from the basics itself. S orbital, p orbital, d orbital, f orbital. S orbital is spherical, like a ball. Okay, very simple, like a ball. P orbital is dumbbell shaped. Dumbbell shaped. You can also look at the dumbbell that you take, or the best way to look at it is, for example, you have a balloon. Let's tie them together. So that's what is a p orbital. This is double dumbbell. So you're basically tying 4 balloons together, and there is one unique one where you have dz squared dumbbell with a donut around it. Okay, f orbital we cannot do it because it's a little bit tricky, but they won't ask you this. Even 3D la kaatumbodhu irukum. So here is a picture of all these actually for your reference. Now they are not going to ask you this, but let's understand how they are arranged. Let's say for example this is nucleus 1s, or first orbital, or first orbit, sorry, second orbital, third orbital. So இது 1s 2s 3s 4s னு எடுத்துக்கலாம், spherical. டம்பல்னு வரும்போது இதில் p orbital இருக்காது, but n equals 2, n equals 3, n equals 4, n equals 2 ல p orbital இருக்கும்ல, so we can draw it this way. How about n equals 3? 3 p orbitals, so they are going to be, this is just a reference, it's not exactly in one axis, but let's say for example this axis we take as px, this is 2px, 3px, 4px. Similarly, if you overlay, you can do the double dumbbell. இதே வந்து நம்ம d orbitals வரையலாம் அப்படின்னா, first is 3d. So 3d, let's put it this way. இது 3d அப்படின்னா 4d. So anytime you draw a dumbbell, sphere எடுத்தீங்கன்னா symmetrical இருக்கும் electrons. Dumbbell எடுத்தீங்கன்னா usually the electrons are always towards the end, and the electrons here are 0. Probability of finding an electron is 0. Okay, that is called a node. Node is a region, okay, where the probability of finding an electron is 0. For example, here I am showing you the nodes. Okay, probability of finding an electron is 0. A nodal plane is not a region, it's a plane where probability of finding an electron is 0. So each orbital has different type of nodal plane. In nodes there are two types. Angular nodes and radial nodes. Okay. Angular nodes are extremely simple. It is given by the value of L value. Okay, it tells you how many number of angular nodes are there. L value on the 3 angular nodes. Radial nodes are given by this value of n minus L minus 1. Okay, total number of radial nodes, we will solve problem based on this. But formula n minus L minus 1. So what is the total nodes? L plus n minus L minus 1 will give you, L goes away, n minus 1 is the total number of nodes that you want to know. Now, for example, I give you 4f. How many total nodes are there? Total equals n. 4 minus 1 is 3. Now, how many are angular? L value, L equals 0 is S. So, S, P, D, F. 0, 1, 2, 3. So, 3. How many radial? N minus L minus 1. N is 4 minus L is 3 minus 1. 0 radial nodes. Okay, this is what it means. Okay. Now, how can you visualize the nodes? Okay. Now, angular node on the romba simple, you can look into the plane at which you can actually see no electron. Okay. Now, if you see, for example, radial node, that's the one that you want to look at. Now, if you see, for example, here, this is a s orbital, okay, 3s, 2s, 1s. So, you have these. Now, imagine that nucleus nadula irukku, and then there is a gap, and then there is 1s orbital. Okay. 1s ku mele 2s, but ana 1s ku 2s ku nadula or gap irukum. That is called a node, radial node. Okay, radial node. That white space is called a node. And then 2s ku 3s ku nadula or gap irukla, that is the another radial node. So, let's say for example, I get 3s orbital. Let's look at angular node. 0. So, an s orbital will never have an angular node. Now, radial node, n minus L minus 1, that equals 3 minus 0 minus 1 is, how much is it? 2. What is the total number of nodes? 2. Now, what does it mean? Again, going to the diagram, you see that the nucleus is here. There is the first 1s. 1s ku nucleus ku nadula oru node kediyadu. Okay. 1s ku 2s ku nadula or white space irukla, adu oru node, radial node. 2s ku 3s ku nadula one irukla, adu innoru node. That is what this is. 2 nodes. Now, why doesn't it have an angular node? Angular node is a nodal plane. Okay. ஒரு பால்ல எங்க plane இருக்கு, எலக்ட்ரான் இல்லாம, அந்த பால்ல நீங்க எங்க தொட்டாலுமே அந்த பால் இருக்கும்ல. Whereas p orbital na I have this, d orbital means I have this, f orbital adhe mari irukkalam. Okay, this is what. Now, here is a picture of all the planes, nodal planes. You don't have to remember, okay, you don't have to remember, but just an idea ku na and picture kaatran ungalku. This will tell you what the angular nodes are. Basically, this is the nodal plane, this is the radial node. Better example, let's say for example, we take 4d. What is the radial node? 4 minus, what is d? If you take d, what it will be? L equals 0 is s orbital, L equals 1 is p orbital, L equals 2 is d orbital. 2 minus 1. So, 4 minus 2 minus 1 is 1. Angular, L equals, L equals 2. Correct? So, they are telling you for a 4d orbital, there is 2 angular nodes. Where are they? Okay. Now, basically what the nodes are is this area right there. இப்போ p orbital எடுத்திங்கன்னா, this is a node. Literally இங்கே எலக்ட்ரான் இருக்காதுல்ல, இங்கே வரைக்கும் நிறைய எலக்ட்ரான் இருக்கும், இங்கே எலக்ட்ரான் இருக்காது, இங்கே எலக்ட்ரான் இருக்கும். This is a node. S orbital எடுத்தா, this is 1s, 2s, 3s, 4s. Now, let's look at 3s. 3s இங்கே இருக்கு. Okay. Now, it is extremely hard to find a nodal plane. I cannot have any. But when I go to radial, okay, When I go to radial, what do I have? N minus L minus 1. N minus L minus 1 is 2. So 1s and 2s nodula, there is one radial node. 2s and 3s nodula, one radial node. So hence 2. Similarly, D ku P ku paakadhu kashtamā irukum, but it gives you a fair enough idea. Okay, so now basically this is pretty much it for your quantum numbers. Idu ulla question varum, I can guarantee you, but quantum numbers are the way you can easily miss a question because of singular, plural. Okay, particularly n plus rule strong ah irukanum. Various orbitals kodutittu endha order nu keppanga paathale theriyum. We will look at it on the problem side. Okay, but this is a chapter where properly do it now. Have your notes very clean, practice problems, make sure wherever you make a mistake in the test, mark it down, so when you revise it one more time before, let's say 1 month before NEET, you are set for it. It's extremely simple. Okay, make sure that you guys answer the quiz that I have posted in Google Classroom. This is open for everybody. The video solution of the quizzes also will be posted in the YouTube. Okay, good luck guys.